Yesterday we covered about sets. So just I will give a quick wrap up on what we covered yesterday, so that when we write code, you are all tuned to what is taught to expect. So we said that sets are unordered in the sense when you add it based on the hash value, it computes for the contents of the objects that you put in. They are put into the set, and when you take it out, they will also be taken out in that order. It is not based on any specific order. It's based on the value of hash that it computes. And we said that the set is mutable, as such you can keep adding to it or deleting it from there is allowed, and it is iterable, but it is not indexed. You cannot index it because there is no order maintained, because it is all based on the hash value that you compute. Since the items are added into the set based on the hash value, the objects that you give it should be immutable. The objects need to be immutable, what is given to the set, but set as such is mutable. You can keep adding or deleting items from there. So there is a major difference between tuples and sets. Tuples themselves are immutable, but it allows mutable objects, whereas sets themselves are mutable, but it allows only immutable objects. So it is only here, which you should remember. And then these are the operations we saw. Set theory, whatever we have learned in our school, all the operations can be done on the sets. And these are the symbols which you can try it out later. These functions we will try to look at it now. Hash I explained you. It's some algorithm or a function with a which is not too complex. At the same time, it gives you the value which is distinctly different, even if the items in the objects are having minor changes. The hash functions are distributed equally so that it will not have any collision while looking for the entry in the set. Thereby you will be able to add them and maintain them in a set. Okay, the hash functions are designed such a way that there are collisions avoided here. And the searching through the hash table is order of 1, because if collision is not there, for every object that you have, there will be a unique hash value that you will get it, and you will be able to locate it within the table, and it's order of 1, and not in, if you increase the number of elements in the set, it doesn't increase the search time. Okay, that's an advantage of having a hash function to access these sets. So whatever you learn in sets about the hash function, it is true for dictionary also. Only difference is dictionary will have keys, and then you will use the hash function to locate the key, and then it will give you a value which for every key that you have in a dictionary. So that we will learn in the next class, in the next week. Okay, so that's what we learned about hash as well as the set. So let us start writing a code now. I mentioned that flower bracket is what is used for keeping the items into the set. We keep like this, and then dictionary will be having a pair of values like this. So both are flower bracket. This is dictionary and this is set. Okay, so now let us see empty equal to this. Now what do you think this is? Is it going to be a dictionary or a set? If I say this and then try to find out the type of that object, will I see a type defined as a dictionary or a set? So let us see. It's a dictionary. Okay, so Python accepts or treats the empty flower parenthesis, brackets as a dictionary and not a set. Okay. Now, how do you create a empty set? So, empty set equal to set and this. So, this is like a constructor. We are constructing a set object with no items in it. So, if you type that, it will be a set. So we have created a set now, empty set. Now I hope this is visible. Maybe I will increase it a little bit. Now let us form my set 1. There is no issue here. So let me create another set, maybe with duplicate items. Now what happens? One more property of set is it will not allow duplicate items to be there, and you know that it maintains the object references. So let us see, when you do this, what happens really internally. It accepts this. Before putting into the set, it computes the hash value of that based on the value of this integer object, which happens to be 1, and then it adds to the set. Now similarly, these values are hash functions are computed, and they will all be yielding, because the contents are different, they will all be yielding at different values of hash. So they will be landing into some different areas in the set. But when I give 4, you will have the same hash function coming out, because if you see the property, it should, for the same value of the object, it should give you the same hash function. It should be repeatable. So for this 4 and this 4, it has already computed the hash and added the item, and then when it gets the hash function for 4, again it will get the same hash function, and it will go and see that this object is already there. It doesn't take this value into it. So similarly, the 4, 5, 6 also will not be accepted. So you don't see that these values are added into the set finally when you print it. So what you give is different from what you get. So that you should keep in mind. And why it is happening is also very obvious, but try to understand the reason behind it. Now, what if I add some item to it? So this is a new item which is getting added, and it should accept it. So 71 gets added. Similarly, you can add any other item, different items. If you add, it will be able to take it. So let us try to add some more, because I want to remove some items later on. Now 70, if I give, it doesn't matter whether you are giving this. Now what if I give, maybe let us do the same 70, I give it as a string. So do you expect this to accept it or reject it? It accepts it. The reason being, this is an integer object and this is a string object. So though the contents are, for us as a human being, the same, but at the same time, literally this 70 will be converted into an integer value, which is totally different from the ASCIIs of, or UINT, the UTF-16 encoding or UTF-8 encoding, whatever encoding it has, that value will be different. So you will see that these two objects are not the same, and it will result in a different value of hash and it will get added successfully. It doesn't reject it unless they are same kind of objects you add it. Now there are two ways to remove an element from a set. So let me remove it. There's a remove command. So let me give the same number which is already there. So 70, integer 70 got removed. Now what if I give a remove command an object which is not there? Suppose 7 is not there in our set. So let me try to give an object which is not in the set using the remove command. So you get an exception. So you need to be careful before you use this remove command with any item. You need to make sure that it is a part of that set or not. So there are commands which I told you. Let me show you that. There are a set of commands which you can use to find out X is in. Yes. So this to be, you have to check it whether it is true, then only you should give a remove command. Otherwise you will get an exception. So let us comment it off. Now what if I want to do really remove an item which I don't know whether it is already there or not, but I want this to accept it, then you need to use another command called discard. Even if the item is not in the set, no exceptions. Right. Okay, I should not write it beyond some 80 column as per the Python law. So let me not write it. Let us not violate the rule. Okay, I am coming from C++ world. So okay. Now what happens? Nothing happens. If the item is not there, it quietly accepts it. It doesn't give you any error, so you are happy. Now let me try out some functions. If you want to check it whether is it a subset of some set. So if you want to compare that, so I will say my set. Maybe I will write 1, 2, 3, 4, 5, 6. Your set. Maybe I will keep 4 of them, 3 of them. So there are some functions which we can use it. Print your set dot is subset of my set. What do you expect? My set, is it a subset of your set? Do you expect this to be false or true? Your set is a subset of my set. Okay, so we are using the is subset on your set. So this is the object, this is the method. You are checking whether this set is a subset of this my set. Since 4, 5, 6 is a subset, you get a true value. Okay, so remember, with respect to what we are invoking it, we are invoking it with respect to your subset, whether this set, your subset, your set is a subset of my set. Okay, so let us do the other way around. Oh, sorry. Oh, I lost it. Now let me do it in the other way. My set, I want to check whether this is a subset of your set, which is false. So you should understand what is what. Now let us use this. Now is superset is what? It has got all the items of your set in it. Okay, so it is a superset. My set is a superset of your set. So that will be true, and the other way around will not be true. That is very obvious, so I don't need to use it. So let us use union function, print my set union your set. So you, because this is already there, your union will be this only. What happens if you do it the other way? You will get the same value because both are same. It's very obvious. So anyway, I will, for the completeness sake, I will give it. This also should be the same. Now let us do the intersection of this. If you want, I can show you the, maybe I will use the code that I have instead of typing. I think I have made it very small, big. So a very, you know that intersection is 4, 5, 6. So let me now go little bit, go quickly. I will take something from here one by one maybe. Okay, I'll take both. I'm sorry. To save time. The difference between my set and your set, and symmetric difference. So if you recall, I mentioned it already. Symmetric difference is this, which are not in both will be shown on the green color. Okay, so what do you expect to see? Diff is between these two, my set difference your set. So my set is a bigger set, that will give you 1, 2, 3, whereas your set is a subset of my set, so you will get a null set. So a null set will be printed like this. It will not print a empty parenthesis, because the empty flower bracket corresponds to a empty dictionary. So when it finds a empty set, it will print it as set, like what we did for creating an empty set. The same thing you get it when you are printing it also. So it will not print as a empty parenthesis, flower brackets, because that corresponds to empty dictionary. And symmetric difference is what you saw here, between A and B, elements in either A or B but not both. So in our set, what is there in either in A or B, because 4, 5, 6 is already there in both, only 123 is there only in one set and it is not here. So you will get 123 as a symmetric difference. Even if you do it the other way also, the same thing happens. Okay, between two sets which is not there in both are printed out, so you get the same values. So I hope this is very obvious. Let us do the iteration. I will use this code. So we can do a iteration on on the set. See here, we are having all the immutable objects, a tuple with immutable objects only. Okay, and then this is an immutable object. They are all immutable, and then you are forming a set. And if you want to add 4, you can do that, and then I am printing it. So very obvious what you get. I am printing out all the items. Now see here, I have added it in this order. I am getting also in the same order in the iteration. Okay, it happens to be like that. Now let me do something. Okay, what if I try to add a set with a tuple objects which have, okay, let me, instead of this, let me have a my tuple with some couple of immutable objects and then one mutable. Now if I say I want to add this, my tuple is a immutable object by itself, but it has a mutable object in it. Okay, so it is unhashable. The list in, understand this. Now tuple itself is immutable. Okay, you cannot change it now, but we know that a tuple can have a mutable object which can be modified also. If I have a list which is mutable, tuple allows it, but that tuple, though it itself is immutable, it cannot be added to a set, because as I mentioned, whenever when you are adding an element into a set, it first finds, it goes into the content of the object, it scans through the complete object to get the hash value. Okay, it is something which is related to the content of an object. So when it is going through this content, it sees that okay, these two are immutable, it's acceptable, but it sees a list. Now the issue here is, right now it can find out a hash value based on these contents 2 and 3, and then it can even allow you to add this tuple into the set. The problem is, what if this my tuple gets modified, because it has a list which can be changed. So if I do that, now next if I give my tuple, it will not be able to get the hash function which is same as what it found earlier. Suppose if I don't know whether I am making sense or not. Let me try to explain it with maybe writing something. See, what happens is, I have added it now. Adding is not a problem because this has a 2 and 3, only these two values are there. It can compute the hash function value taking these contents, and then it can add into the set. Now later on, I may have this my tuple which has modified this 2 3 to some 2 3 4, and now it is inside my set. Now next I am asking, is a subset, okay, or is it element is available or not, whether this particular element is there in the set or not. If I try to find out, how will it know? It has to now compute the hash function. Now it will find the hash function, but now when it computes the hash function, it has to compute it based on this 2 3 4 value, which will be different from what it computed earlier. So this object, though it is still present, my tuple is still pointing at that object, it will not be able to locate it because the new hash function will be different from what it computed earlier, because the object has changed. So it will be a inconsistency. The object is still there, but you are now going to add into a new thing, or this will be lost forever. It will not be found later on. So as per the because of this logic, it doesn't allow you a tuple with a mutable objects in it. So it allows this tuple it allows, but this it will not allow. So we need to avoid doing it. Okay, so let me comment off this. I hope this is clear. Please let me know in case you have some doubts. Let me see whether any questions are there, or you guys are. Oh, sorry, there is some question. So after line 17, will my set 1 and my set 2, will they refer to same location since their contents are same? Good question. Let me look at the, I don't know, now 17 and 18 would have changed. Let me see. No, it will be same. I hope it is not modified. What is the question? My set 1. Okay, what was the content? Let me run it. This is 1, 2, 3, 4, 5, 6. Yeah, this 4, 5, 6 also same. Okay. Okay, let me understand the question now. Will my set 1 and my set 2, will they refer to same location? See here, these two are two different sets, okay? What I mentioned was within the set, the keys are maintained, okay? It will not go across the set to verify that, okay? It is like two containers, two different containers. My set 1 is one container, my set 2 is another container. This has got a set of same item 1, 2, 3, 4, maybe 1, 2, 3 suppose. I am creating another container with 1, 2, 3. Now whenever I am adding something to it, it is going to look into this key or hash value and then going to add something or delete something. So they are two different things. So there is no relationship between them. It is like I am having a same book, you also have the same book in your house. It's okay. Is that clear? If am I answering this question, Akash? Do you understand?
Hello, sir.
Yeah.
So, sir, I was asking both the sets, my set one and my set two, they compute hash on like one, and other one also like computes hash on one. So they will be two different hashes on the same value of one.
Uh, okay. Let me try to understand it. Okay. Now, in case if you are asking me whether they compute the same hash or not, let us check it out. Okay. There is a function hash which will give you what is the hash value it computed. Okay. Um, I don't know whether I can do it on my set. No, I need to do it on a particular element. Okay. Can you come again? What is the question, please? I didn't understand.
So, sir, I was asking suppose we have one set, as you said, like my set one containing 1 to 3, and other set also my set two containing 1, 2, and 3. And the as you said, like they work with hashes. So I compute it when I want to access like 1, 2, or 3, I would compute hash on that particular value. Similarly for like my set 2 also, I would compute hash on those values 1, 2, and 3. But since the contents, like there is 2 in my set 1 and there is 2 in my set 2, the hashes when we'll compute on those keys, will they be same hashes for my set 1 and my set 2?
Yeah, you are right. Yeah, the hash value will be same. Let us try to find out. Okay. So yeah, I understood that. Sorry, I understood the question now. So let me do that now. Print. Sorry. Hash of 2. Okay. Let us take hash of 2. Now, where is it? Um, I think, yeah, here, this is the value. Uh, 2 gives you 2. Okay, let me see whether what happens when we do a string. You see here, when you try to find some hash value of a string, it gives you this. Okay, now let me explain that because you have asked this question, so let me bring it up here. Now another string a b c, maybe e. Okay, now what I do, I am trying to find the hash of two strings which is little different, only one bit different actually. Okay, d and e is a one increment from the ASCII value of d to ASCII value of e. Let us see the value of hash that you get for both. Okay, if you compare the previous run and this run, it is ending with some 9498, some 2885, 9498, 2885. So it is repeatable. The hash value computed for the string on every run, it's not random. It computes the same value on every time you run it. Okay, now I change one bit in this one character here in the string. What I get a hash value is a totally some different number altogether from what was found for earlier. This is what is called equally distributed. Okay, this the property that I mentioned somewhere, that hash value that you compute distributed equally. Even if there is a small change in the value, they are drastically different. That's why the collision doesn't happen. Okay, if that's how this hash function works. Okay, to answer your question, for my set 1 and my set 2, when it is computing the hashes for these values, it will get the same thing. Okay, because we saw that for 2 it computes 2. Actually this hash happens to be for integers, they just return 2. I don't know. Okay, it's how it is done internally, what is the hash value done, how it is computing. So it is same. Okay, maybe let us try to see whether I may get for 3 what I get. Then the equally distributed may not work, whatever I claim. Let us see what happens for 3. It computes the same thing. For integer values it is same, but for any string or any other objects which are content of them, it gives you some different values. Okay, so that's how the hash function is used. I think internally this is the hash function which is used by the set to compute and then populate the element or access the element inside the set. Okay, that's what I learned. Maybe this is how it happens. Okay, hope Akash I answered your question. It will compute the same value. Okay,
Okay, thank you.
is it clear?
Yes, sir.
Okay, thank you. Okay, this fellow is distracting. Okay, now let us see some more stuff, some interesting stuff, anything that I can show you. Now let us look at the enumerate. I think that we have to see that enumerate is there. So let me take out from here. Will it be interesting? No, I don't think so. So this I will just show you for demonstration purpose. I already told you list is not acceptable at all as a element. So if my set is there already, I have, I think some my set is there, so I try to add it. Now what happens, I am adding a list with the L1 and L2, a list containing a list. Okay, it will give you unhashable. So that I already explained, I think. So let it be there. I think the same update also. Update is adding it. We're now adding some element to the thing. Add is one thing. Update is another one. You can use it. Okay, to add some new element into the existing set, but it will verify always whether it is able to get the hash or not, and mutable objects are not accepted at all. So that is clear. Now let us see, we can do some pop. Okay, now this is interesting. Let me show you some pop function. um, Before I pop something out, I want to print it. Okay, so my set is having this element. When I pop it, it happens to get the first element, but it is not guaranteed that you always get the first one. Okay, so it depends on what exactly. It's a random arbitrary element is removed. Okay, it's not always the first element that you added or what is there. There is no order maintained within the set. For be clear on that. Now, okay, let me update one mutable object. Sorry, immutable object. I always get confused. Now my set is having some values. These are the values, and I want to update with another element, one more element, so that it accepts. Now you may wonder that this, when I update it, okay, let me ask a question now. Based on what you see here, can you tell me what is happening? When I updated a string and then I printed the my set, what I get is this. Can someone tell me what is happening?
Sir, unpacking
Sorry?
the string.
Yes, you are right. Okay, unpacking the string. So it unpacks the string and then adds it to the set. Okay, so we didn't say that, but it does it. So that update takes the object, unpacks it, and then element by element it goes into adds it, and it will also check whether already that element is there or not. So now let us see that whether it happens or not. I will copy paste. I will say, okay, two more, okay, similar, or I'll write similar element. Now it is going to unpack it, and then this element, this ELM are not going to be added now. Okay, so after adding similar element, so you will see that LEM, this capital M and small m are different, and element, they are all only one element is there. It doesn't accept. So it is very careful in making sure that duplicates are not added into the set. Now what if I want to add it as a whole string? Okay, how do I do it? Update is not the function to use. You can use add function. That's the difference between update and add. Using add to pass the entire string, okay, as an element. Okay, entire string. Okay, to add. Okay, I don't want to say add. So now what happens? Similar element, it completely gets added. It is not going to unpack it or something. So add you need to use if you want to unpack, without unpacking, if it needs to be added. So let us see what is the description that we saw here. Add adds a single element to the set. Okay, update adds multiple elements to the set by union of itself with others. So this update function, what happens is, more than saying unpack, it actually forms a set before even passing it. Okay, to be precise, if you need to be very, if suppose in the interview somebody asks you, you don't have to say unpack, you can say that update does a union of the set that you are passing. Okay, it treats this as a set, and then you are calling it on another set 1 maybe. Now set 1 is already there, and set is what is accepts, and then it does a union of this with the set 1. That means what, whatever you pass, it should make it into a set first, and then make a union of this and this. So effectively, this whatever you are doing here is equivalent to calling this function with the set, constructing a set. Okay, let me show you. It is similar to calling this as set and doing it like this. Okay, it is similar to this, and anyway, of course, it will not add anymore because you have done it multiple times. You did it here, you did it here, but you are doing it with a set. So this is what is happening here. Okay, this is not unpacking the string and then passing it. It is unpacking it, forming a set, and then computing a union of this with the my set, and that is what is coming out as an operation. The total operation done is this. So if you look at the description, update adds multiple elements to the set by union of itself with others. So multiple elements, it says multiple elements and unions of others. So maybe it may not form a set, it may do a union of that set, every element with this. Okay, it may not do this completely. It may unpack it, and then each element it will union of that with the my set it will do. Okay, so internally it may be doing it. We need to look at the library function to say what is happening. So this is what is happening. Okay, so that you remember. That's what I wanted to highlight. Now enumerate, yeah, enumerate also I should show you. How much time I have? Another 10 minutes. Okay, maybe 5 minutes. That's all, we will finish it off. Where is enumerate? Did I have it here? Where is it? I am able to see there, and I am not able to see enumerate here. Okay. Now, when you enumerate my set, what happens? It is very same as what you saw with the other collections. It will send you a tuple. Remember, the parentheses are optional for a tuple than a comma. So when you say this, it actually fills it with the index for every element for the element in the my set, and then it forms it gives you a list, a index for every element that it is there. Okay, so you know that it is iterable. Okay, and the order in which it takes is based on whatever the hash functions it computes. Okay, and whatever the values come out of my set is enumerated here with an index and the value. So that's what you get. What if I do this with just one object? Okay, let me enumerate this again. But if I give a tuple, enum tuple, okay. Now print enum tuple. Now what happens is, if you do not give it as an individual element, it will not initialize it. It will send you an enum object every time. So now the printing will be like an enum object, 0, 1 and 1, 1, 2 if you see that it is the same, except that individually it is not assigned and you are having the enumerated object coming out. Okay, so that's all about the enumeration. And okay, anything else I need to show you? Hash I already told you how it is computing, and this also I already told you. Tuple with immutable object and mutable object, it doesn't accept, so nothing more. I think that's all I have. What I have not shown you or covered is about using this. What is it? These symbols. You can also do this by this. So maybe we will try one if you want. What is the time we have? No, almost I ended it. You can try it out if you want. Okay. How to use it with this? Okay. Two sets you can form and then print it. Okay. Let me show only one maybe at least. Just for the completeness sake, print my set 1. It is not there. My set is not there. Okay, so let me create a any other set I have. Oh, sorry, I wrote it here. I should have written it in our class. I have this here. Okay, sorry. Okay, so 2 3 4, let me print what is there in my set, and otherwise we will not be able to make sense out of. So my set is having all this. My set 1 is having this. I think 2 3 4 are the common stuff. So ampersand is for intersection. So that is as simple as this, like a binary operator. You can use it with these operators, okay, which is easier than using those methods given in the set. So I think this is enough for set. I think whatever I wanted to cover I have already shown you. Any questions from anyone? Okay, yeah, okay, you have answered it. Any questions from anyone? Hope this is clear. Okay, so let us stop now. At least you have a 10 minutes break before you get into another class. I don't want to hold you. Have a nice evening, late evening. Good night.
Excuse me, sir.
Yeah, go ahead.
Sir, I have a doubt.
Yeah.
In lab third assignments, we have to initialize the lists of list.
Correct.
But if it is not a list of list, I mean the depth is 0, then it should not be initialized.
Correct.
Okay, sir.
Yeah, I think I have given some examples, right? So you should be able to handle it. Okay, if there is nothing in there, empty list should give you the empty list. Okay, but if you have multiple lists inside them, then you go ahead and initialize it. Okay.
Okay, sir.
Yeah.
Thank you.